increasingly quickly. This one diverges at a constant rate. Okay. How about exponential demand? Is Cole here? Cole Walters? Okay, does someone else want to do exponential demand? Yeah, go ahead, you talk.
So it's the formula is PQ plus prime PQ times Q. So
yeah,
it's 1 minus log Q plus derivative of that is 1 over Q times Q.
Yeah.
That's 1 minus. That's 1 minus log Q minus 1.
Yeah, and what's that?
Equals minus log Q.
Exactly. So it's exactly minus log Q. And so the demand was 1 minus log Q. This is minus log Q. So these have exactly the same slope. It's just that this is below this by 1 unit, right? That's the only difference. Right? This is just 1 below it, and it's always 1 below it. Okay. How about for this constant elasticity, David? Can you derive for this constant elasticity demand, 1 over Q to the 1/2, what the marginal revenue curve is?
So I take the derivative of Q.
Yep.
And it's negative, I think, 1 over 2Q to the 3 over 2.
Yep. And then what do you do with that once you get it?
And then I multiply that by Q and then subtract it from Q.
Yep. And so
I get 1 over 2Q to the 1/2.
yes, I think that's right. Yeah, exactly. Perfect. So this one is exactly half of this one, right? And because the demand goes down as the quantity increases, this means that they're going to get closer and closer as the quantity increases, right? So when the quantity is very small, these will be very different. As the quantity increases, these will go down, and they'll get closer. So that is, the marginal revenue is a constant fraction of the price, and therefore they'll get closer as the quantity increases. So just to give you pictures of these, this is the constant elasticity demand, and you see the marginal revenue is a constant fraction of the demand. Here's the linear demand. They start at the same point and then they diverge at constant rates. Here's the negative exponential demand. There's a constant difference between them at each point. And here's the concave demand. They start at the same point and then they diverge increasingly rapidly. Right? Now, what I've done here is I've depicted the horizontal axis as being the marginal cost curve, so that we can figure out how we figure out what the firm's correct quantity and price is. So if the marginal cost curve is the horizontal axis, we find the intersection between that marginal cost and the marginal revenue curve, which is the red curve in each of these. We then draw a line up from there, because that's the optimal quantity, right, to what price that corresponds to, which is on the demand curve. And we draw a horizontal line over to determine the price that that corresponds to. Right? And that's what we've done on each of these. We find the intersection between marginal revenue and cost, take the line up to demand, and over to find the price. That's the general way that you find the price associated with the monopolist optimal price. Okay. So another way to write marginal revenue is as the price times 1 minus the inverse elasticity, 1 over the elasticity. And Shaolun, I might be pronouncing this wrong. Xiaolun. Xiaolun Cheng. No. Does anyone else want to explain how we get this? Well, I'll just go through it. It's fine. So, the elasticity, right, is the negative of the derivative of quantity with respect to price times price over quantity, right? That's the elasticity formula. Because this is the percent change in quantity for a percent change in price, right? So that's the same as 1 over the elasticity being the percent change in quantity over the percent change in price over the percent change in quantity, right? Which is dP dQ times Q over P, right? So that says that price divided by the elasticity, if we multiply both top and bottom by price, we can cancel the two prices. And we get negative of the price over elasticity is P prime times Q, right? And that's exactly the difference between marginal revenue and price. So, if we then just bring price on the other side, we get that marginal revenue is equal to price times 1 minus 1 over the elasticity. Okay. So what that tells us is that a firm is never going to produce at a point where its elasticity of demand is less than 1. The reason is that if the elasticity of demand is less than 1, then the marginal revenue will always be negative, right? Because in that case, the monopolist will actually be able to get more revenue by producing less of the good. And given that they have to pay more cost when they produce more of the good, they're never going to want to do that. Okay. The second thing to notice is that the elasticity of demand is the key determinant of the monopoly power. Because if the elasticity were infinite, so this whole term were 0, then the price would just be equal to marginal cost, right? So as the elasticity gets smaller, the firm has more monopoly power. And this is pretty intuitive given what we said before, because the elasticity sort of measures how big of a firm am I in the market. If I increase my price by 1%, how much does that change the demand? If it changes it by a ton, if the demand curve is very flat, I can't affect prices very much. If it changes it by a little, then I'm a big part of the market, and I can affect prices a lot. Okay, so if we rearrange this formula, if we set this equal to marginal cost, and then we bring price times the elasticity over onto one side, bring marginal cost onto the other side, and divide by price, we get price minus marginal cost over price is equal to 1 over the elasticity. This is called Lerner's markup pricing rule, or elasticity pricing rule, and it says that the difference between price and marginal cost divided by price is 1 over the elasticity. So this is a reason why elasticity is often used as a way to measure market power. If elasticity is low, you have a lot of market power. And so as a result of that, sometimes in antitrust, people will use the difference between price and the markup and cost divided by price as a measure of how much power the firm has in the industry. Okay. This number is often called the markup, but it's really a relative markup. It's the markup relative to price. Markup being the difference between price and marginal cost. You could also do the markup relative to marginal cost rather than relative to price, and you would get 1 over the elasticity minus 1. Or you could do the ratio of price to marginal cost. That would give you the elasticity over the elasticity minus 1. Or you could do the absolute markup, just the difference between price and cost, and that would give you the price over the elasticity. These are basically all alternative and very similar ways of measuring market power, but in some contexts, one can be more useful than the other. So the standard Lerner formula is quite nice because it's just very simple. It's just 1 over the elasticity. So when the elasticity is easy to measure, or is salient, or you can think about it easily, we'll use this formula. The price-cost ratio can be useful because it's especially when marginal cost is constant, it's very related to the profits that the firm makes. Just the straight markup can be useful for the same reason. The absolute markup is particularly useful when costs and therefore prices may not be positive. So a good example of that would be advertising markets. So many newspapers and many websites are given away for free, or the price is 0. So in that case, the ratio of P minus MC to MC, to P is going to be infinite. It's not even going to be well defined, right? And the reason that they give things away free is because actually their costs of having someone read the newspaper are negative, because they're getting paid by the advertisers to hand out the newspapers, right? So in that case, using the Lerner pricing rule makes no sense, even though the firm has some market power. Okay. Or credit cards are another example of that. People pay you to use your credit card, right? You get points every time you use your credit card. And the reason is because they're making money off the merchants every time you use the credit card. The marginal cost of having to use the credit card is negative. And so it doesn't make sense to use the inverse elasticity. Okay. Now, in order to set prices, in practice, firms don't just automatically know what the demand curve is, right? They have to try to figure that out. One way that they can do that is by experimenting with the price that they charge and seeing what the marginal revenue looks like. And in the past, firms had to sort of guess about this or gradually try out different prices and try to learn. Because the internet has really totally changed this. So in the internet, you can very easily try charging different prices to different people, and you can really figure out a lot about what demand curves look like. And many companies do this all the time. So Amazon, almost every time you go onto Amazon, it's like trying a different price to see whether you'll buy or not. And probably the most common platform for experimentation like this is eBay. So people on eBay, sellers on eBay, are constantly experimenting with the reserve price they charge. This is the minimum price that you need to pay in order to win the auction. And the way you can figure out that they're doing this is the exact same seller is selling the exact same thing for different prices on different days or at different auctions at the same time. And this auction can actually generate, now you'd think that this is like the minimum price that you need in order to win the auction. It's not like the price directly that they're selling the thing for, right? So it's not exactly the same as a demand curve, but it's actually quite closely related. And Sam, could you explain why in an auction the reserve price could be quite similar to the price in a normal auction, or how they might be related, or in a normal demand curve, and how they might be related?
Sure. So the average price is going to go up, just like in the demand curve, when the minimum price that people are bidding goes up.
Yeah. So why might that happen?
In the auction or in,
yeah.
in the demand curve? Isn't it just like if someone's willing to pay higher, then
yeah.
like the average is going to be higher, just intuitionally?
Yeah. So exactly. Imagine that Sam bids above the reserve price, but everybody else bids below the reserve price, right? And imagine that Amanda was the second highest bid, right? If the reserve price hadn't been that high, then you would have paid the price that Amanda bid rather than the reserve price, right? And so having a higher reserve price means that if I sell it, at least on average, I'm going to sell it at a higher price, right? So go on with what you were saying. You're then going to say, why? What else happens when I raise the reserve price?
I don't know. I just know that like the average would
yeah.
go
Well,
up.
so that